Now we will work through the practice problems on projectile motion, and as always, these will be most beneficial to you if you try to solve them on your own first. If you can work through the problem on your own and figure it out by yourself, that will help the ideas and the concepts to stick in your brain better than if you simply watch someone else work it. So try these on your own, and then if you need help, check the solutions or watch the videos. But here's the first one. A rock is thrown horizontally off of a 100-meter cliff. So let's draw this. Here goes the rock. Its initial velocity is horizontal, and we're told that the cliff is 100 meters high. And it lands 95 meters away. Okay, the path here is a piece of a parabola, and that distance is 95 meters. At what speed was it thrown? So this is what we're looking for, the initial velocity. Now the key to solving any projectile problem is to do the horizontal and vertical independently. It's kind of like two separate problems. We work a problem with the horizontal motion and we work a problem with the vertical motion, and the horizontal and the vertical have no effect on each other. The fact that it's moving horizontally here has no effect on the time that it takes to fall down to the bottom. So we do those two separately, and I'm going to do the vertical first, and I'll explain why. But let's write down what we know vertically. Vertically, I know the acceleration is down, and that's 9.8 meters per second squared. And for this problem, I'm going to let down be the positive direction. And so that means for my distances, that's going to be 0 meters up here at the top and 100 meters down here at the bottom. Setting up my initial position as 0 and the final position as 100 arranged that way, with 0 at the top and 100 at the bottom, that's consistent with down being positive. And what's also consistent with that is that the acceleration is 9.8 meters per second squared, and it's positive because the acceleration due to gravity is always down, and in this problem I'm saying down is positive. And then I can also say this: the initial position is 0, that's the initial height, and the final position is 100. And note that I don't put in 95 for the final position. That's the final horizontal position. I'm just doing the vertical motion here, and the final position vertically down at the bottom here is 100, the way I've set this up. And there's one other thing that I know. The initial velocity is 0. And you might think, wait a minute, the initial velocity is what we're looking for. That's true. But when we're just considering vertical motion, and I know that it's thrown horizontally, then the initial velocity horizontally or vertically has to be 0. Because it's thrown horizontally, there's no initial up or down motion. Now it develops some downward motion as it falls, but the initial velocity is entirely horizontal. So when I'm only considering the vertical motion, I can say v0 is 0. And then I know this equation. Y, the height, is equal to y0 plus v0t plus 1/2 at squared. And because the initial velocity was 0, this term goes away. v0 times t will be 0. And the initial height is also 0, so that goes away. So the equation simplifies to this: y is equal to 1/2 at squared. And if you do the algebra and solve this for t, just rearrange this equation algebraically, t comes out to be the square root of 2y over a. I'll back up and show you that. What we do here is multiply both sides of the equation by 2, and on the right, the 2's cancel. And then we divide both sides of the equation by a, and on the right, the a's cancel, and all we're left with there is a t squared, and it's equal to 2y over a. So if t squared is equal to 2y over a, then t is the square root of 2y over a. And so let's put in those numbers. That's the square root of 2 times 100 meters. Y there, that's our final position, 100 meters, over a, which is 9.8 meters per second squared. So you take out the calculator. 2 times 100 is 200. You divide that by 9.8, and then you take the square root of all of that, and it comes out to 4.52 seconds. Now we were just dealing with the vertical motion, so this is the time that it takes to fall from a height of 0 to a height of 100 down there. So now that we found the time, we can use that with our horizontal motion. And that's why I did the vertical first, because I knew enough information vertically to find the time. Now I'll do the horizontal. And I'm running out of room here on the screen, but the horizontal isn't going to take up much space. Horizontally, I can use this equation, x equals x0 plus v0t plus 1/2 at squared. Now this equation is the same equation I was using over here. I just typically write an x there when I'm dealing with the horizontal and a y when I'm dealing with the vertical, but conceptually they're the same. Now horizontally, if I have 95 meters here and it's moving this way, I'm going to think that to the right is the positive direction. And so this is a horizontal position of 0 and that's a horizontal position of 95. So my horizontal goes from 0 here to 95 over there. And this 95 here just indicates the change. So think of a number line along here with 0 and then going up to 95. Now horizontally, this is really simple. My initial horizontal position is 0, so x0 goes away. And horizontally, there's no acceleration, so this second term goes away. So this equation just reduces to this. X is equal to v0t. And then that's very simple to just rearrange algebraically. v0 is x over t. And you don't even have to write this. If you're solving this problem, if you recognize that there's no acceleration horizontally and the initial position is 0, you can just go straight to this. Distance is velocity times time. That's just like distance is rate times time, like we have from Algebra 1. Distance is velocity times time. Rearrange it to solve it for v, and then just put in the numbers. x0 is, or x, I'm sorry, the final x is 95 meters over the 4.52 seconds that we found over there, and we get our answer as 21 meters per second. And I'm going to scoot this over here to make a little room. I'll just slide that over there, and then I'll write the final answer here, 21 meters per second. So when you're doing this problem, if you tried to do the horizontal first, what you would do is you would find that you didn't have enough information to solve the problem. You would get to this point and you'd be trying to find v0 and you don't have the time. So that would be a clue that you would need to stop there and go do the vertical first. But that's it. That's a fairly standard projectile problem. You should make sure you understand all of those concepts and the calculations involved.